Well, hello everybody. Welcome into Great Atmosphere here on February 28th, Wednesday, February 28th of 2024. Got plenty to talk about today, and we're going to dive right into it. We have our first major severe spring transitional season system making its way across the United States. Left quite a bit of turmoil throughout the Midwest overnight, unfortunately. You hate it when big severe weather happens overnight for safety reasons, of course. And, of course, I don't wish severe weather on anybody. But you know, as meteorologists, this is certainly the time of year when people start getting excited, looking at radars again. It's an overall fun time to be a Met. So, just gonna take a look at our True Color GOES satellite imagery over the contiguous U.S. right now. We have some major components to figure out here. We have our big low that has completely occluded and wrapped up, currently sitting up in the far northern reaches of Quebec and Ontario, Canada. We have a cold front which you can pretty much see extending all the way down from there, and then we have cold air channeling in, high pressure and dry cold air making its way across the Great Lakes. That's where you see all this fantastic lake effect snow occurring. And on the back end of that system, as it moved in, you could actually see some snow that fell over Minnesota and Wisconsin. Actually, it was some of the most significant snow that the area has seen all winter, which is saying a lot about how bad the winter has been. But that's typical for a dominant El Nino season. We also have our next area of disturbance that is making its way through the Pacific Northwest. Going to be, as this general upper level flow pattern starts to phase together, where we have our polar jet kind of dipping in like this, and then we have our subtropical jet kind of going like this. Well, this is all Arctic air that is technically on the northern side of that polar jet. So this area, any kind of precipitation that it gets, and of course the West Coast is no stranger to precipitation this winter, it's going to come in the form of snow and blowing winds. So blizzard warnings are going to be in effect for a lot of the upper Mountain West going into the next few days. We also have significant wildfires over the Texas and Oklahoma panhandles that got exacerbated on the back end by this big windbag system that came through. It was actually some pretty interesting satellite imagery. Unfortunately, I didn't get the chance to save that, but you could see on the satellite itself the winds exacerbating the existing storms or existing fires that are out there. It's quite interesting. And then we have our main system itself. Caused a lot of hail in the upper portions of Illinois, and then there were several tornado warnings throughout this area, particularly in northern Indiana and far southwestern Michigan. The southern tier of the system right here that was supposed to start to kick off did not last night, thankfully, for the areas around the Ohio River Valley. Largely a discrete thunderstorm threat was supposed to take place in that general area, according to the SPC. Kind of a late enhanced risk was put out there, kind of in the 11th hour, ultimately did not come through. So that's a good thing. But today the main story is the cold front that's sweeping across the eastern seaboard and kind of delivering our first major thunderstorms across the region. We can take a look at what this looks like at the surface level just to be able to see what those winds look like, as we have our clear definition of wind shear here. We have cold, dry air confronting this warm Gulf Stream air mass, and we'll be gradually pushing that out to sea as high pressure starts to build in behind. We have our major low, we have our Bermuda high, which is becoming more dominant. And that's generally what the pattern is across the eastern parts of the U.S. And this is an interesting point to make. Whenever you get such a significant, shift in winds like this and the surface levels, that kind of makes the upper levels have a much more amplified speed effect. It's called the thermal wind relationship, and this is what it looks like up in 250 millibars, about 6 kilometers up in the atmosphere. Just some rocket ship winds that are going through here. I can't really see what it is because of my timer here, but I'm sure there's plenty of aircraft that are trying to take advantage of this particular jet. Those are some wicked stream winds. And I'm sure in the exit regions this is an area of, what do you know, it's divergence aloft, And this area is, of course, under the gun in the next few hours to receive that cold front itself. And then, of course, we expect in the left exit region for that indentation to be somewhere in this area is where our surface low would form. And our surface low is currently existing about right there over the Hudson Bay. So everything kind of coming together as planned. And then we have our Rocky Mountain high over low blocking. Polar jet still working its way, still very strong. And then we have our split flow with the subtropical that is currently going to go in and out of phasing together in different ways, shapes, and patterns over the next week or so. Certainly will make things interesting. But taking a look at the local storm reports across the Midwest last night, anything in a kind of a pink diamond that you see there is a hail report. Anything in a brown triangle would be a high wind report. I believe we have thunderstorm, just thunderstorm damage, generalized with yellow boxes, and then the red triangles would be a tornado report. I can kind of zoom in, and they're not necessarily confirmed tornadoes by any means. These are all going to be verified by the local National Weather Service offices over the next few days. They have to do that for insurance companies and whatnot. They are the official say-so when it comes to getting those checks in the mail. So we see waterspouts near Gary, Indiana, funnel clouds near Tinley Park, and then all the way out here, more funnel clouds. Kind of scary up in the northern regions of Chicago. Possible tornado north of I-90. And this one was actually one that I saw last night before I went to bed. There was a tornado that was very clearly visible on satellite radar and velocity data that impacted this particular area near Marshall, Michigan. So altogether, and then you can see actually on the back end the radar overlay. This is all lake effect snow that's come in on the back end. Snow observations all throughout the state of Wisconsin. I'm sure those will start to populate over Michigan over the course of today. And then across the southern tier, we're expecting a little bit more of a tornadic threat in a discrete sense, but that just did not come to fruition. Just wasn't enough convective energy available at the time, and just couldn't overcome that cap. Certainly had a lot of parameters in place, but just not enough to be able to set things off in a severe way. So the end result was a big windbag storm, and that is kind of the deal that we're experiencing now over today, with wind being the primary threat, with some areas receiving some more particular severe parameters in the way of maybe hail and lightning and that kind of thing. Mainly kind of over central PA, far western New York, and then portions of northern Georgia and South Carolina. Those are the areas where we saw the sun kind of peek through the clouds today, kind of create a little bit more solar radiation at the surface, work to break that cap, and we'll talk about that in just a little bit. Another thing to kind of take note is what our temperature records look like across the United States over the past week. All of those red dots was either breaking or tying or breaking a daily or monthly record high. So it's been an exceptionally. I know there were some stations where we had highs that were being broken that were 12 degrees higher than they would. That was normal. Particularly, it was a big deal down in Mexico this week. They've gone through a terrible winter in terms of drought and heat. But in terms of the U.S. in the past week, it's been exceptionally warm. And we can see that through the Chicago Midway Airport. You can see what, like yesterday, we had a record, or it wasn't technically a record. We got to 74, the record 75, set back in 1976. But you can see that the observed temperature range was 53 to 74. And typically in the normal temperature range for this time of year, it's 26 as the low, 41 as the high. So the low for the day was over 12 degrees higher than the typically expected high for the day. So that it was quite a significant event for sure. But you can see, of course, over the course of the entire winter, we've been warm, with the exception of that January cold snap that came through, obviously, right pretty much all around the normal high normal temperature range or in the red for the majority of the winter. Certainly it's going to be one for the record books for sure in terms of mean average temperature across the course of the entire season. So I mentioned earlier about the potential for some severe weather across the southeast today, and that's mainly because we saw some cloud breaks across the majority of where that surface trough kind of began. And you can see anytime where you get these cloud breaks right out ahead of the storm frontal system right here. So we can maybe pause this. So you see these little areas right in here where you can kind of see the ground. Right next to GSP, in and around the Peachtree City, Atlanta area. Those are areas where the sun peeked through and ultimately started to heat the ground so that the surface became a lot more warm before the actual frontal boundary moved through. And that ultimately did something where it's called breaking the cap. And try to kind of simulate what that means per se. So like in a normal temperature sounding, we'll have this. Let's say that this is your temperature profile, and then in the mid levels you'll get, and this is your dew point profile. It'll just be like that, and it'll kind of go in this kind of direction until it hits the surface. So this is with height. So Y, and then this would be skewed obviously, but this area would be your temperature, and this would be your dew point. And then how they develop convective available potential energy is you take the LCL point, which would be about right here, and then points, you go all the way up until you hit the equilibrium level up top. This is a very terrible explanation, but ultimately the main issue is that if there's warm dry air aloft, that is called the cap, because all of this area right in here, this particular region, is called convective inhibition. That is what keeps you from experiencing a thunderstorm. And then you would have anything that would appear on the right and underneath the temperature profile, but underneath the partial temperature line, that would be your CAPE, or your convective available potential energy. That's your thunderstorm fuel, as the broadcasters will like to say. So if you have too much convective inhibition, mainly due to that warm dry air layer in the mid levels, then you are just not going to get as robust thunderstorm activity. But if you were to have the opposite, where you have let's say something like this, just a little inversion, and then your typical dew point like that, right? Then, and the temperature at the surface goes up because of that solar radiation heating. That's why it's moved from like this general direction over to the right. That ultimately breaks that cap, and then the LCL still exists right here, the lifted condensation layer. You go all the way up, and there's just no inhibition in the way. So what that solar radiation has been doing all day, essentially, is just kind of working to erode that cap so we can get some robust thunderstorms. And we can see that here in our surface analysis of the CAPE. I believe this is the mixed layer, if I set this up correctly. Yep, so this would be your 100 millibar mixed layer, which is the primary area for storm genesis. So anywhere that you see this blue area would be areas that are capped. They have high convective inhibition, and it's going to be hard for robust, very tall ecotop thunderstorms to be able to form. But anywhere that you don't see that, and you see this red, and you see these red outlines and shading hatching, that's areas where you just have straight pure CAPE. And that's where you would expect to see more thunderstorm activity, especially with the higher, more value CAPE that you get. So, and what we're experiencing now in that particular region here in northern Georgia is area that is uncapped due to that solar radiative heating. And right now they're coming through with some pretty robust thunderstorms, and I can show you what the radar currently looks like right now. Severe thunderstorm warnings all throughout the area. We can take the radar of Peachtree City just to kind of see it. And I have several family members that live in northern Atlanta, and they reported to me before these warnings went out that it sounded like a freight train when these storms were coming through, just because the winds out ahead of it were just so strong. And we could see the high res velocity data. This is a very useful data parameter where you have very strong winds going towards the radar site, denoted in green, and then you have winds that are going away from the radar site, which in this scenario is located here in Peachtree City, in red and orange. And then you have areas that are yellow, They denote high winds, and lighter greens denote high winds as well, until you get out into areas where they don't have anything in terms of cloud, in terms of storms. So you can see just how strong these winds are throughout the course of the area, and then you see a little bit as well, actually quite significant winds coming into the GSP area. Very interesting that we have a little bit of rotation on a mesoscale area right here, but I would assume that's generally due to the shape of the QLCS squall, so I'm not too concerned about any actual convective rotation. I believe this is mainly a downdraft Cape scenario, and we can kind of look at the Cape downdrafts here. Woo, that is some significant D-Cape. So D-Cape is essentially, well, how do they describe it here on the SPC? I'm curious. Used to estimate potential strength of rain-cooled downdrafts within deep convection, similar to Cape. Larger D-Cape reverse stronger downdrafts. And downdrafts, that's where you get your wind when you're about to encounter a thunderstorm. The stronger the downdraft, the higher the wind gust, or the gust front, or further out the gust front will be when it eventually hits into your neck of the woods. So these are some pretty elevated D-Cape values. I would expect that is the primary concern out of the SPC in terms of what severe parameter is the issue here, and it would be wind. And we can see that from the all hazards weather map that these are all high wind warnings all throughout the eastern seaboard. I'm not entirely sure why Raleigh and the Central Virginia office have not put out them here. I would assume because that area has just been underneath clouds all day, so they're probably anticipating a little bit of a dissipation. But the coastal plain, I'm sure, will start juicing up a little bit more because it definitely had some time earlier in the day under the sun. And then same into western and northern upstate of New York, where we had a similar effect there as well. So that is what they're looking at. And then we could see the anticipation of that winter storm actually come through. Blizzard warnings in the Sierra Nevada, expecting feet of snow in the area, should be one of the final big impacts of creating snowpack for the Upper Mountain West. They're pretty excited about that. Take a quick look at the 500 millibar height anomaly map. This is kind of the pattern that we've been seeing over the course of the past week or so, where we have our major troughs coming out of the Pacific Northwest and then highs building in on the eastern seaboard, just creating that southwestern flow that we just love so much that opens up the Gulf, creates a lot more moisture for us here in the eastern parts, and then also brings in that polar jet into the polar jet down, merging, phasing with the subtropical jet that is very strong due to El Nino, and creating a bunch of a ruckus here in the central plains specifically, with any shortwave troughing that we would expect to kind of make our way into the southeast, and that's kind of what we're going to be expecting here. We should see a shortwave trough start to form going into, you can see just a little indentation there into the central plains, creating a little bit of a problem, and then we have even more troughing that'll start to wrap itself up. So this is kind of just the pattern that we're seeing across the ensemble guidance, and it should last for quite a bit longer. I know the GEFS right here is forecasting a little bit more troughing into the northeastern region with ridging out ahead. That could signal a little bit of a stopgap valve to this. We're going to have to keep taking a look at that for at least the next 2 weeks. This is generally the pattern, probably a new system coming through every 5 to 7 days, depending on how fast and how negatively tilted these troughs are. We can take a look at what the NAM guidance is suggesting here. We can go forward and see that the end result of that cold front moving past and then through with snow on the back end. And then that shortwave trough starting to make its way, kind of forms a little bit of a longhorn low and opens up the Gulf temporarily, kind of caps off the central plains, creates more of a southeastern rain soaker event. I think that's definitely going to be the story going into the rest of the week. Could get a couple inches out of this across the majority of the southeast according to the NAM. And then we'll take a quick look at what everyone's expecting from the flagship models here for the GFS and the Euro. We see that opening up of the Gulf and with the shortwave trough going into our weekend on Friday. Starts to open it up quite a bit, and then we see our new system that made its way across that's making its way across the Pacific Northwest. Interestingly enough, this one is negatively tilted already, so that means that it's already starting to wrap up quite considerably, and it's going to make its way further north, and it's going to be quite quick in its movement. And the end result of what that looks like downstream is going to be, depending on how far north it actually gets, is going to be the main point of contention. Does a low form in that lee side of the Rockies? And where does the frontal positioning actually end up? We can move forward in time. Not a lot of agreement between the two flagship models going into next week. GFS is bullish and more of a QLCS system. The Euro is much slower. And then eventually both systems kind of open up as high pressure sits off of the East Coast and begins our next major system in earnest. Ironically enough, about this time, 5 to 7 days out of next week. So that's all I got for y'all today. I appreciate y'all tuning in. This is a little bit of an abbreviated one. I'm in a little bit of a rush this evening, and I had some work stuff I had to take care of earlier in the day, so I appreciate you tuning in for this abbreviated episode. Once again, my name is Zach for Good Atmosphere, and I'll be back with another forecasting video for you on Friday of this week. Take care.